I'm also one of the Google Summer of Code students from last year, and I also kept stuck with the BioJS library and got one of the core developers for last year.
Correction. You actually drove the release of BioJS 2.0.
Maybe yes, maybe no. We can discuss this later. But today I'm not here to present a specific component, but I'm going to talk about time travel with BioJS. There's only one problem. I'm not alien, even though I look like this, and time travel hasn't been proven to work with wormholes yet. Might be in the future. So I have to stick with the old school concept and trying to make predictions based on all the knowledge I have gathered in the last year. And I think before we look at what is very important for BioJS in the future, we have to look at actually who makes this decision. And at the one point, we have BioJS, we have many independent developers who have their own interest. For example, some developers might care about Internet Explorer 6 or 7, whereas others care about the speed of a component. And a third one might care about using ECMAScript 6 or even the newer ECMAScript 7. Which you can already use today. However, on the other side there's GitHub and our social community, a place where we bring all those components together and actually try to figure a common schema and a common model that we can actually agree on all those decisions. And one of those decisions that we have to make within BioJS is to create a standardized API. And actually, a BioJS component look like a Docker container that from the outset, from your web page, you don't see anything of the BioJS component, and every BioJS component behaves in the same way. So the way you inject data in a BioJS is always the same. The way you update a data model in BioJS is the same, and all the other API calls need to be the same if you want to go on and let BioJS grow and integrate with other projects. By the way, all the projects here have two things in common. First of all, they all deal with biological data. Yes, even GitHub has PDB files and FASTA files. And the second is, they do want to visualize those data, but they lack the money and the developer time to actually develop those components. So this is why they actually need those standardized APIs to actually display BioJS components in Galaxy or on Wikipedia. And I do imagine that in maybe 2 or 3 years' times, if you actually go to your favorite protein on Wikipedia, you actually see a BioJS component which is wrapped there. Or the same goes for GitHub or IPython, or maybe even in the eLife applications, which would be super awesome to see. However, there's a very small catch here. And the thing is, what Michelle also mentioned recently, is that the web evolves, and the web is constantly evolving, even though you're sleeping. And you might remember that last year, in the summer of last year, we have chosen Browserify as module loader. And here's just a short list of other module loaders, like Component, Duo, Webpack, and ES6 modules, which have been developed in the last year or have made production ready. So you see there's a huge amount of development going on. And it's always very hard to make a decision on all of those module loaders. However, there's a common concept, or a different idea, which Ian talked about in the morning. And I think those are web components who have become a standard and are already implemented in Chrome since Chrome 37, which means roughly since 8 months. And since one month ago, Google officially released Polymer 1.0. So the first official release of Polymer. They have also reduced the polyfill, which you needed in other browsers, to an actually manageable size, which means you can actually use custom elements and also HTML imports and templates in your web page. And I do imagine that using web components could be the way to go for BioJS 3.0, because it actually brings all those common concepts to a very easy to use component, because all components look the same and you can just modify them like you want, and you don't even need JavaScript. And whether you now use BioJS MSA or BioJS PDB or BioJS whatever, it's always just an HTML tag. So like Polymate does for YouTube, where you have your YouTube tags or your Google Map tags, there should be biological tags which actually use biological data which are used for biological data. So if I could fascinate you to work on BioJS, please come to the hackathon tomorrow. We'll speak about improvements to the BioJS specification, and where we might talk about using web components and other technologies.
So what will you have tomorrow in the hackathon for people who don't have experience with BioJS, but they want to get involved in understanding how to reuse, how to start doing something? What are we going to have tomorrow?
So tomorrow we will actually group people in different interests and then let those people start brainstorming. So there will be one track based on a BioJS specification. Then there will be another track based on actually developing components. So tomorrow we will actually see what people are coming and what interest they have, group them together, and then let them brainstorm in the morning so they can work on the same project for the entire day.